Hey everyone, so today we'll be revising linked list. Sorry I was not able to revise the other remaining linked list yesterday, but let's get started with remove the nth node from end of the list. Okay, so okay, remove nth node from end of list. Let's hide this code. Given the head of a linked list, remove the nth node from the end of the list and return its head. Got it. So what can we do in this case? What are the constraints? Are there any constraints on this? So number of nodes can be SZ. Number of nodes in the list is SZ. SZ is 1 to 30. It won't be null. So node value, okay, got it. So, and what's the value of n? N could be less than equal to 1 to less than equal to SC. So, yep, got it. So make sure that we have to make sure that we ask our interviewers about the constraint so that we can come up with the edge cases if we are missing out on anything before jumping on to the question. So let's see what the question is asking. Given the head of the linked list, remove the nth node from end of the list and return its head. So I have 1, 2, 3, 4, 5 and the n given me 2 is 2. So from last I have to remove the nth node, right? Okay, got it. So the first thing that comes to my mind is, why don't we reverse the string, reverse the list entirely, then do the reach till the n, and then keep track of the previous, and then make previous to point at the currents next. So doing that will solve our problem, and then we can reverse it back again. So that is one of the possible solutions we can do on this one. So the time complexity of this would be O of n simply, but is there a better way of doing it? So yeah, but in case if this question comes, uh, I can straight away tell the interviewer this, and if he or she, if the interviewer wants me to code this out, this would be a good starting point. And then yeah, once the interviewer asks us how we can improve this, then that is a problem. Okay, so how will I be able to reach to the end? So even if I use the slow and fast pointer, I'll reach to the mid of the linked list, and the end node will definitely reach to the end. But how would we know where does our n lies? That's basically the question, unless and until we don't know what. So yeah, even if, like, I was thinking that either ways I guess I have to calculate the number of nodes um, in this, and then yeah, figure out where that n lies. If n is greater than the mid or less than the mid, then based on that we can traverse this, but anyways we'll be traversing of n by that point of time, because calculating the number of nodes will eventually require us to traverse entire linked list. So that is not a great thing to do. So in 5 minutes we were able to do that. How can I get, okay, suppose let's say our interviewer hands us maintain 2 pointers and update one with a delay of n steps. Oh, okay, got it. So maintain, oh yeah. You can, what you can do is um, make your fast pointer to go n steps, and then yeah, it will, so fast will move 1 2 2, n will be here, like the fast will be here, then from the next point onwards until the fast reaches the end, um, slow will move n steps apart eventually, and we'll reach here, and then we can yeah, basically basically keep the track of previous, and we can delete it. What if we have to delete the first node itself? So for doing that, n is equal to, okay, if let's say n is equal to was 5, 1 2 3 4 5, so our first n is equal to 2, right? So n is equal to 1 would be, okay, n is equal to 5, which means we'll go to the nth last node, and yeah, slow would be pointing to the first node, and yeah, slow's previous should be dummy, right? Dummy, yeah, slow's next should be, like the previous should be dummy always. Dummy, let's see if we can code this out. Let's do this. But yeah, like we came up with 2 solutions, that's a good thing, but the other one is O of n, but I guess when you compare it with the constants, then this the first one, the second approach would be the better one that we described. Okay, so we have let slow is equal to 0, let fast is equal to 0. Okay, let's keep them at this stage, and so n will be always in the bound, right? So we don't have to worry about that. While So for let I is equal to 0, I is less than n, I plus plus, what we'll do is fast is equal to fast dot next. We'll keep on moving the fast node, and let pref is equal to, and let dummy is equal to new new list node of -1. Okay, so pref should be dummy and got it. So while fast dot fast dot fast or fast dot next or fast dot next is there, what we'll do is slow equals to slow dot next, and fast is equal to fast dot next. Sorry, they both would be pointing at head. Okay. Yeah, so, and for every stage we have to make sure that we are capturing the previous one, the slow, and in the end what we need to do is pref dot next equals to slow dot next, so that we'll skip out this and return dummy dot next. So yeah, I guess this should work. If not, okay, so let's so our fast move ahead, like n 0 to till 2, I guess it should have moved till 2, and then while fast previous slow dot next, fast dot next. Why this isn't working? So our dummy hasn't pointed to anything right now, so that's why the empty is coming. So let's do this. Dummy dot next is equal to head. Yeah, okay, that worked, but why was it taking so much time? Fast or fast dot next. Yeah, I guess fast dot next. Why is it a bad idea? Yeah, we might have reached to the null by the end of this, so probably because of that. Okay, cool, it got accepted. So of n would be the time complexity and space would be of 1. Let's see how we have done it previously. Yeah, see, we did this dummy dot next is equal to Okay. Oh, I see. By pointing it to dummy, we are reaching to the one node before that, and then yeah, but it's more or less the same thing. Whichever you feel intuitive to you, um, it should it should do it. Um, so yeah, I'm glad that I am not memorizing stuff, and it's a pretty good question. Remove nth node from the list. Let's do a second one. So yeah, we did it in 15 minutes or so. Okay, so the next one we have copy list with random pointers. I know this one. Like I came up with a pretty intuitive solution for this. Um, so yeah, a linked list of length n is given such that each node contains an additional random pointer which could point to any node in the list or null. Okay, construct a deep copy of the link of the list. The deep copy should consist of exactly n branch new nodes where each new node has its value set to the value. Okay, basically what we need to do this, I know this question, I remember this question being solved. Let's see how many companies likes to ask this question. A lot likes to ask this question, so let's star mark it. I haven't done that. Linked list. So yeah, basically we need to create a copy of this, right? This So the linked list in this scenario is pointing to the next node as well as a random node, like any random node in the entire linked list. So yeah, basically, uh, and we need to create copy of each node, right? So let's say we start with the first node, we create a copy of it, but there is no way of us knowing, like making the new node point to the next or the random node before even it exists, right? If so, every node we need to create a new node, right? A copy node of it. So if we start from the first, there is no way the other would have been generated. So for us to make this happen, what we need to do is first of all traverse the list entire list and create a hash map where you store the newly created linked list address. So these are nothing but memory addresses, right? So yeah, we store that in the map, and then again traverse through the linked list, and at this time we know, we know for matter of fact where the next and the random pointer would be because we have stored everything in the map. So we can basically take the newly created node and make it to point make it to the point, the list node that is being stored in the what in the hash map. So that's that. I can We can even go through the solution. So map new, see, current is head. So what we do is we create a new node and then set that new node to the currents, whatever the current node that we are on, and then we traverse the next node and we do the same for the entire thing. And next what we do is current is equal to head again, and we traverse the current, and this point we take the new node from the current, which is copy of this current, and then we need to now make the new nodes random and next pointer. We need to connect them, right? So it's just like connecting wires now. So if map.get random is there, then we connect it or we connect it to null. if map.current.next would be a node somewhere in the hash map. So if it is there, we connect it, or else we'll simply do null, and current is equal to current.next, and yeah, we are done with this. So the overall time complexity would be O of n, and space complexity would be O of n as well, because we are storing it in the hash map. And is there a better way of doing it? Of one space. Oh, there is a way. There is a way that we can do it in of one space. Wow, I did not see the solution. But yeah, it's wow. Should we just go ahead and see what NeetCode has to say on this? What should we do? Mm-hmm. Okay. So I'm thinking, what should we do in this case? Yeah, I'll probably watch NeetCode video on this. I thought that would be a pretty. I didn't think that this can be done in off one time. Okay. So what I'll do is take a break of 5, and then I can come back and do this. Okay. Or you know what? Let's do it. Let's push ourselves to do this, because if I once go, I tend to take a long time breaks, and I procrastinate. So let's do this.
Hey everyone, welcome back, and let's write some more NeetCode today. So today let's solve copy list with a random pointer. So we're given a linked list, and so this is a pretty big description of the problem, but it's actually more simple than that. So basically, you can see down in the example, this is what you should pay attention to. We have a pretty ordinary linked list, right? So this is a node, and you can see each node has a next pointer, right? So it just keeps going. It's singly linked list for the most part, right? And then we get to the end, right? So this is the end of the list. This is the start. The only difference between this and a regular linked list is that every single node has one extra pointer. It has a random pointer. So you can see that the first node has a random pointer going all the way to null, right? You can see that the second node has a random pointer going all the way back to the first node. You can see the third node has a random pointer going all the way to the last node. So basically what the deal is that every single node has a random pointer, and that pointer could be pointing anywhere, right? It could be at null, it could be at some random node inside of the list, it could be at any of those nodes. So it has a random pointer, but it also has a next pointer, which is, as you would expect, just pointing at the next node. All we really need to do with this linked list is create a copy of it. By that they mean a deep copy. So really what we're doing is for every single node, we're allocating new memory. We're actually creating a new node, right? And so you can see we have 5 nodes in the input, so we're going to have to create 5 nodes in the output, right? So that's pretty straightforward, right? The only difficulty comes, though, is from the random pointer, right? Clearly, these nodes are going to be linked together, right, in linear fashion, but we also have random pointers, right? So for this node, we would have to create a random pointer pointing at null, right, which is pretty easy. That's what was happening with the first node. But for the second node, right, we'd have a random pointer going back to the first node. And for the third node, we'd have a random pointer going to the last node. So it's not too bad, right? The only difficulty though with these random pointers is that, take the third node for example, right? Let's say we start cloning the node, right? We create a clone of the first node, then we create a clone of the second node, then we create a clone of the third node, and the random pointers, this one's going to be at null, this one's going to point back at the first node, but the third node, right? We know its random pointer is going to be at the fifth node, but we haven't created a deep copy of the fifth node yet. So how can we assign a random pointer before it's even been created? Well, the answer is we're going to do two passes. We're going to have two loops. And so with these two passes, what the first pass is going to do is we're simply going to take each of these input nodes, right? And we're going to create a deep copy of the nodes, right? That's all we're doing. We're just going to create copies of these nodes. We're not even going to link them yet, right? So that's what the first pass is going to do. And in addition, the first pass is also going to create a hash map where we map the original node to the new node, right? So we're going to map every old node to the new copy. We're going to do that with a hash map, and this is going to take place in the first pass. And in the actual second pass is where we're going to actually do all the pointer connecting. So we know that every node is going to have, pointers to the next node. They're also going to have some random pointers as well, right? Like this is going to have a random pointer to the last node. And we're going to leverage our hash map that we create in the first pass, right? That we create using the first pass of our algorithm. We're going to leverage that hash map to map every old node to the new node. So for example, we see in the original third node, its random pointer is pointing at the original. And so if this does map and linear memory, O of n memory, because we are having to store every single node inside of our hash map. So with that being said, let me show you the code. It's actually easier than you might think. So remember,
Okay, I guess NeetCode also did the same thing. So we are good on this. If the interviewer asks of one, let's hope not. He'll ask, but if the interviewer asks, then we have to see. So good for now. We'll take 5 minutes break, and then we'll jump back onto the add two numbers and linked list cycle, and then we'll also then we'll try to do the find the duplicate number, LRU cache. Okay, LRU cache is the most important question. You cannot miss it before you're going to an interview. So yeah, I need to do that perfectly, like understand what's going on in there, and yeah, if I can come up with a solution in an interview, that would be just amazing. So yeah, that is it for this video, and yeah, this is the 100th video on my channel. So yeah, I didn't think that I'll get so used to talking on a stream and solving it, but it really does help me to communicate my thought process in a better way, like as if I'm talking to an interviewer. So I really put forth my best thought process that I can come up with during the explanation, and I tend to solve it live instead of watching the solution, so that people who are struggling with such questions can relate to it and see that yeah, all of us struggle. So yeah, like it's just me trying to solve these questions, trying to land a dream job of mine. Hopefully this helps anyone. I know I'm not the sharpest coder of all, but yeah, if this helps, then then that's great. I'm contributing to the well-being of a programming society in one or the other way. But yeah, um, thank you so much. Yeah, even though I have not been getting a lot of views, that is totally fine. I never started this channel to gain views or to um, for any monetization purposes. I just started it as a way to communicate properly. And today, yesterday my back got severely hurt, so I'm having difficult time even standing or getting out of the bed. So that's one hiccup. But yeah, that's not going to stop me as long as I don't let it to. But yeah, it is what it is. We all have to deal with our ups and downs. Um, so yeah, this was a short um, statement for my 100th video. Hopefully, I still keep on doing this, and hopefully in future I can make more polished videos rather than just streaming randomly. Uh, but yeah, like communicating with you guys or talking on camera does really help me, motivates me to, you know, just don't go through the problem and go and instead go to the problem effectively. And yeah, so that's all, guys. I won't bore you more. um, yeah, so see you in the next stream. We'll do add to numbers and linked list cycle in the next